Okay, this is the second part of Practical 5. And what I've done so far is I've loaded in the results we ran on day 3, the real model of Southampton, water, and then the one where we just increased Bramblebank by 5 metres. And what we're going to do is just look at some different ways of comparing results. So in your assignment you'll look at a dredge. How do you go about actually assessing what the implications of this dredge are? So one of the easiest things we can do is just overlay current and vectors. But before we do that, just so I don't get confused, what I'm going to do is just change the names of these, because at the moment it's velocity UV. What I'm going to just put is going to call this one baseline, so I know this is the one. Before I change, let's do it for the free surface as well. So this is the one before the dredge, and this is the one after the sorry, not the dredge, Bramblebank. So let's just call that BB scenario. Copy that. And free surface as well. I don't think I'll use the other variables. Okay, so what we can do, one of the easiest things is just to overlay the vector. But first of all, let's just load in the geo-rectified image from day 4. So what we can do is bring in our baseline first. Oh, sorry, not. Let's do the U and V baseline because we're interested in current vectors. The baseline of the scenario. Now what I do is I always try and have default colors. So for the baseline, I'm going to make the vectors blue. So let's call them monochrome. And let's make those blue. Right. And for the scenario, I'm going to make the vectors red. So what I can see is if there's any differences. Let's click on animate, and then we can zoom through here. And again, it's probably good to do some scaling, so I'm just going to stop that there, and let's scale that to 500, just so they're not so overpowering. And scale the baselines as well. You have to do both. Okay, what we can do now is zoom in here. Zoomed in a bit too much. My computer's a bit slow. So now we can have a look up here, and we can see in these areas there's no differences because they're red, but here you can see a difference now. So the baseline is going over Bramblebank, but the scenario isn't because we've dredged out. And you can see that it's changing the currents here. It's a slight change of direction, change of speed. So that's a good way of just looking at it. And again, you could sync this with a point. So let's just put a point in the middle here. Call it EG 0.1, something like that. And again, we could look at the free surface, tools, extract a time series at that point. Pop this onto a 1D view. Now I'm going to make this blue because it's my baseline. Let's just drag that over there. Drag this one down. We could extract a point from the scenario as well. Again, you probably want to label them just so you don't get mixed up. And drag this one in, and we're going to make this one red. it's not clear for some reason. But again, you could sync the views. So if we click on the 2D view, go File, View, Sync with the 2D view, and then as we animate through here, we can see what is happening. The red line should come on in a minute. So we can look at, for different tides, for high water, low water, we can sort of compare the current speeds and see where there are differences. Okay, so that's a useful thing we can do. The next thing we can do is actually calculate different plots. And to do that, I'm going to use the calculator. So let's go up to the velocity baseline here. Go Tools, Calculator. And what I'm going to do is I'm going to make my baseline A, and interested in the magnitude, my scenario B. And I'm just going to subtract A from B, so B minus A. Let's call this, I'll just keep it simple and call it diff, and this will be meters per second. And we can run it for all of the time steps here. So let's evaluate that, save it to, I'll save it to day 5. Let's call it diff. So this will give us a difference in speed. Because it's the magnitude there, it's going to give us a difference in speed. I don't know why sometimes it gives that error. Okay, so what I'll do is I'll do a new 2D view, bring on the rectified image, and then let's bring on this difference. What we'll do is we'll make it a surface, or well, actually let's do filled contours. What I'll do is I'll change this color scale. Now here, let's go from 0.3, intervals of 0.1. You can see these are horrible numbers, but hopefully if we do this, it should round them up quite nicely. And what I will do is I'll change this one to be white, and these ones to be shading of red. So let's go from yellow, orange. So you can just click on the color to change it, and red. And now what we'll see is different plots. So let's animate that and run through. And now we can see differences. And as you can see, that the main differences occur around that region. So here the flow speeds are speeding up at this particular time in the tidal cycle. Here they're slowing down, as you'd expect, because water. Now you have to be careful as to which way you subtract. So I always do the scenario line as the baseline, then positive values show an increase in current speeds, negative values show a difference in current speeds. And you could actually drag this difference into your earlier view here, and you could look at flow vectors. You can have your flow vectors on top of the difference plots. Again, it's quite a nice way to do it. You need to drag this up to the top. Let's drag the difference up. And then we can see our differences over our flow vectors. In fact, the vectors should really be above. So put our flow vectors on the top. There we go. That's really what you want there. So you can see where the differences are. And that really is the end of Practical 5.